All right, so there we start looking at the wave motion. Now, waves are very important topic in physics, mostly it comes. But before we continue, we're supposed to understand what a wave is. So, a wave is a disturbance that transmits energy from one place to another as it travels. Now, an example of a wave that I can give you is phone waves. Those are waves. My waves are phone, those are waves also. Do these, when you're making phone calls, it means that you're sending a wave. Do you need energy in your phone for you to be able to call someone? Yeah? No. You don't need energy. So your phone can even be low. So the more you call someone, your phone does not drain. Have you? Your phone drains. Why does your phone drain? Because as you are transferring that energy from your phone to another person, as it is moving from one place to another, energy has to be transferred as well. That's why you come at the more you go, your battery is going to drain. Even in mobile net, my phone also energy is what? Also energy. You come and see the battery. Very good. The more you call, the more the battery drains. Why? Because those are an example of what? Waves. As you are sending those waves, signals, also some energy is what? Being transferred from your phone to the other place. That's why if your phone is 2001. Yeah, you completed school 2004. We used to use my BlackBerry, I think if you remember. BlackBerry even at battery low is that battery to shut off sunga pange coin until you charge it. So that is what a wave is. Then there are two types of waves, two main types of waves. There's what you call transverse waves, and there's what you call longitudinal. What are transverse waves? These are waves in which particles vibrate at right angle. Meaning that in other books, you're not going to find it to say transverse waves are waves in which particles vibrate at right angle, but you're going to find to say transverse waves are waves in which particles vibrate perpendicular to the direction of the of the wave. So it can be at right angle or perpendicular, but you can just say vibrate at right angle to the direction of the wave or perpendicular to the direction of the wave. How? If you throw maybe anything on water, maybe even a boat, during slave trade, we used to carry a boat. So boating at the end of pamanzi, but what is happening to a boat? Each like very good. It is going where? Upwards, also going where? Downwards. But what is it doing? Is it just stagnant like that? No, it is what? Moving. So as it is moving, what angle is being made there is what? 90 degrees. This is an example. If this was a particle A, in a transverse wave, this particle will be moving in this direction. Even here, this is 90 degrees. An example is what? Water wave. So kakokonga the mataya, or maybe the boat, yenda again, a choker, yenda again, but it is even there. That is how waves move. So they move at right angle or at what? Perpendicular to the direction. An example is the water waves. Apart from that, in the radio waves, which falls under electromagnetic waves. When you come to electromagnetic waves, you'll be able to understand what electromagnetic waves are, what are the properties, and what they do. Okay, now there's an example now. This is an example of a transverse wave now. In other books again, that's why you see a book of space apart, so they can write. You write it like this. Chua, like that. Then kabwera apa, just like this. So mzapeza na huko na kulika line. Okutoka apa, kufika apa panzi, call that as what? Amplitude. It's the same as where yagabe apa down na papa bottom. This is amplitude, this is also what? Amplitude. Apa pamwamba is what? Crest. Also this is what? Crest. The distance between two successive crests is called what? Wavelength. But we'll come to the symbols. The symbols for wavelength is what? Lambda. But we'll come to that, which is the next lesson tomorrow. We'll look at now also the calculations and also the symbols for wavelength and the like. Now, how many complete waves can you see from here? How many are there? If I'm saying from here up to here, it's one complete wave. How many complete waves are here? Two. Very good. So one from there up to here, number one. Then from there up to here is what? Number two. So even here it is one, then what? Two. Two and what? Is it quarter or half? Very good. 2.5. So here there are two complete waves and the and a half. Yeah. So sometimes I was to say, can you maybe a question, especially in paper 2 physics, it's even there with the catapult. But about X, what is represented by what X? Check the catapult. The question is that is even exercise I'm giving you. Even now, Mazakupasa party, Nikachana, Mazakupasa party, Y. Can you identify the letter what is on letter X and what Y? On X there is what amplitude and Y is what wavelength. Sometimes they will even ask you to say, can you find the amplitude? Mazakupasa kutoka paja kufika hapa nizingati 18 meters. Can you find the what amplitude? Can I say the amplitude is 18 meters? No. It means that half year or half year. It means I'll say amplitude is equal to what? 18 divided by what? 2. Mean that amplitude is what? 9. That means that ukupamwamba nishani 9. Fancy ni what? 9. Why guys? It's positive and what? Negative. So kuzungangana hapa ni 9, hapa ni 8, hapa ni hii 9 izangana na same values, but this one and this one no have what? Same values. It's more like it's a decrease in this manner. If this is 9 and this is 9, ya next ingakala chani 8, na izangala chani 8, ya next izangala chani 6 or 7 2 2 until ya kufika chani 0. An example katika mgamini kama hapo kaso. Mimi kabwela so, okukanina kabwela so, kaenda chape kata reduce until kafika chani a straight line again. But the distance here and here to be what? The same. Ya hapa na hapa to be what? The same. Ya hapa na hapa to be what? The same. Na hapa na because it is one wave. So this wave on top cannot have different number as the one which is down here, because this one and this one will consist of one wave. I don't know if you get it. Very good. So you should know that diagram so it is what? Transverse what? Wave. And then diagram so spring, it is a longitudinal what? Wave. So I'm pass so up positive 9 up so pass chape chonze. Or maybe pass chape chonze up no kamba maybe up and 6. Can you find the period? Period means one complete what? Wave. If 2 waves are completed in 6 what? 6 seconds, how many? What will be what will be the time for one wave? What do? You divide. So one wave, it will be equal to what? The total time for the 2 waves is what? 6. Divided by how many waves are in 6? 2 of them. Mean that 2 into 6 is what? 3 seconds. So one wave to complete is taking how many seconds? 3. So nisha papali 3, now papali 3. So 3 plus 3 becomes what? 6. Just in case exercise, Nami Buru more. I've already explained here. Zaiwan exercise. Very nice. Very nice exercise. So amplitude is the maximum displacement of the wave from its rest position. The wave at this moment is what? At rest. It will start increasing. When it reaches this maximum point, that is what we call amplitude. It's more like the amplitude in physics, we call it as amplitude, but in mathematics we call it as what? Maximum value or minimum what? Value. This is the maximum value, this is what? The minimum. But they both represent what? Amplitude. Are we okay there? So again, the distance from here up to here is also called what? Wavelength. Okay, we are saying wavelength is the distance between 2 successive what? Crests or what? Troughs. Or to my troughs, crest. So the distance between this trough naka is called what? Wavelength. But again, from this crest to the other crest, it is also called what? Wavelength. As simple as that. Aka, that's why na chetu hapa kusha explain, because aka kari very what important. Na tuma ABCD tuma kwenda mkatafute to check questions how they come under this. Then crest, it is the highest point, trough, it is the lowest point, and the wavelength, it is the distance between 2 successive crests. So know what a longitudinal wave what a transverse wave is, and how is the category. Category kaone kachape so inshoziba kwa kachani transverse. Basa kule tena to we no polo kuza chapati what type of a wave is shown above. Just so chabe, whereby the particles is vibrating at right angle or perpendicular is called the what? The transverse. We're good there? Last, longitudinal waves. In a longitudinal wave, particles vibrate parallel to the direction of the wave. Even 10% I use the color. Now, in here, an example is the waves of a spring. We see a spring in mind. Spring magara wa idonzo mona, then wachishani wa iboiza. So it will be izakara yo donzo mokapa, then abagara chani squeeze. Put again. You have seen a spring before, or I show you. I show you per Google the diagram of a spring. Okay. Kuri ichi chamene chimakala na makala so munasoberepo oli mamukombona not you spring imwe pamana chi spring chite so chaenda uko chabwera uko si yoyo mamukomboni si yoyo Ngasomera mayadi, you understand? Apa pamene patangonuka is called what? Rarefaction. Very important. Sometimes kama kwenda ka question kapa chape chi spring I think na ukatafredi mulimo. Karimu kapa chape spring ngobora kama apa kama apa ni papi, apa ni pashani pa R. Ngobora kuzati what is represented by what? By P. So, but the minute they are squeezed together, it's called what? A compression. They are compressed. You're compressed together. But they're squeezed together. But where there are spaces, it's called what? Rarefaction. But where they are closer, it's what? A compression. So, kuzi but compression, they are together. While it's rarefaction, you are you are what? You are rarefaction. But when you are becoming together, you have engulfed each other. You are what? Compressed together. You get it, eh? If this is particle A, how does this particle move if it is a longitudinal wave? Does it go up? Does it go up? Or it goes what? Sideways and also what? Sideways. Why we're talking about it is it vibrates what? Parallel to the direction. So it does not go up or down. No, it just goes in within. So, but for a transverse, we're talking about kind of chani, pamwamba, pansi, patakachani, kavendera, making what? A 90 degrees. Nish akanikachani, transverse, akanikachani, longitudinal. Cadafloid, the paper cadafloid, I show you. There's a question that came like that. I want to show you. Unless if there are questions there. So it means that the amplitude is in between these two spaces, and then one wave is equal to one J, or wavelength is equal to what? One wave there. So apakuziba chape mzivanje pepa ma compression and what? Rarefaction, because these are the most important one. But can kuziba towards the amplitude. They will ask you to find the amplitude, but mostly it's rare that they can ask you to find the amplitude under this. But this one is the most important one. So let me show you a question how it comes. Unless there are no questions there. We are all safe? Very good. You people are very intelligent.